Welcome to Coding Share. We got the idea about database from previous video. If you haven't seen the previous video, first watch it, then watch this video. This video topic: Database Management System. What is DBMS, Database Management System? A database management system, DBMS, is software that enables users to create, manage, and manipulate databases. It acts as an intermediary between the user and the database, providing efficient ways to store, retrieve, and manage data. DBMS systems handle tasks such as data storage, organizes and manages data in tables or other structures. Data retrieval, enables querying data using languages like SQL. Data manipulation, supports data insertion, updating, and deletion. Data security enforces user access controls and maintains data security. Data integrity ensures data accuracy and consistency. Concurrency manages multiple users accessing the database simultaneously. Backup and recovery ensures data is safe and can be recovered in case of failure. Now let's explore 4 popular DBMS tools: MySQL, PostgreSQL, SQLite, and Oracle. MySQL overview. MySQL is an open-source, widely used relational database management system, RDBMS. It is known for its speed, reliability, and ease of use and is a popular choice for web applications. Key features: open source, free to use with a paid version, MySQL Enterprise offering additional features. Cross-platform, works on various operating systems including Windows, Linux, and Mac OS. ACID compliance, supports transactions ensuring reliable data integrity. Widely used in web applications, powers major websites like Facebook, Twitter, and YouTube. Scalability, can handle small databases as well as large-scale applications. Community support, large active community providing extensive documentation, plugins, and integrations. Use cases: web applications including WordPress, Magento, and Joomla. E-commerce platforms due to its performance and scalability. Data warehousing in certain environments. Advantages: easy to install and set up. High performance with complex queries. Great for handling web-based applications. Disadvantages: limited support for more advanced features like custom data types or full-text indexing compared to other DBMS tools. PostgreSQL overview. PostgreSQL is an advanced, open-source object relational database system known for its flexibility, standards compliance, and robustness. It is one of the most feature-rich DBMSs available, with strong support for both SQL and NoSQL features. Key features: open source, like MySQL, PostgreSQL is free and open source. ACID compliance, fully transactional and supports complex data integrity constraints. Extensibility, highly customizable with support for custom data types, operators, and indexing methods. JSON and XML support, natively supports JSON data and is often used in environments that require both relational and document-style data storage. Concurrency control, uses multi-version concurrency control, MVCC, ensuring high performance with simultaneous transactions. Cross-platform, works on Windows, Linux, and Mac OS. Use cases: applications requiring complex queries, advanced indexing, and data analytics. Enterprise-level applications requiring scalability and performance. Geospatial databases using the PostGIS extension for geographic objects. Advantages: extremely reliable, scalable, and extensible. Supports advanced features like table partitioning, indexes, and full-text search. Can handle large datasets and complex queries better than MySQL in many scenarios. Disadvantages: slightly more complex to set up and manage than MySQL. Steeper learning curve for beginners. SQLite overview. SQLite is a lightweight, serverless, self-contained RDBMS that is fully embedded into the application that uses it. It is widely used in mobile and web applications due to its simplicity and portability. Key features: serverless. Unlike MySQL or PostgreSQL, SQLite doesn't require a server. It is a file-based database. Lightweight, very small footprint, making it ideal for embedded systems, mobile apps, and small projects. Cross-platform, works across different operating systems like Windows, Linux, Android, and iOS. Zero configuration, requires minimal setup and configuration. ACID compliance, supports transactions and ensures data integrity. Use cases: mobile applications such as Android and iOS apps, embedded systems and IoT devices, prototyping and lightweight applications with lower transaction volumes. Advantages: no need for installation or a separate database server. Great for small to medium-sized applications where simplicity and speed are priorities. Portable and easy to use in development. Disadvantages: not suitable for high-volume, concurrent transactions. Limited scalability compared to MySQL or PostgreSQL. Oracle Database Overview. Oracle Database is a commercial, multi-model DBMS that is widely used by large enterprises for managing vast amounts of data. Known for its high performance, scalability, and security, Oracle is often the DBMS of choice for mission-critical systems. Key features: enterprise-grade, offers advanced features for security, performance, and data management, making it a top choice for large-scale enterprise applications. Multi-model database, supports relational, document, graph, and key-value data models, making it versatile for different application needs. ACID compliance, fully transactional with robust data consistency guarantees. Advanced security, offers features like data encryption, user access control, and auditing. High availability, with features like real application clusters and data guard, Oracle provides high availability and disaster recovery solutions. Cloud integration, strong support for hybrid cloud environments with Oracle Cloud Infrastructure. Use cases: large enterprises requiring high performance, scalability, and security. Financial services, healthcare, telecommunications, and government applications where data integrity and uptime are critical. Complex data warehousing and analytics. Advantages: extremely robust and reliable for handling large-scale, mission-critical applications. Comprehensive set of features for managing security, transactions, and performance. Strong support for both on-premise and cloud-based solutions. Disadvantages: expensive licensing costs, which can be a barrier for small to medium-sized businesses. Complex setup and maintenance, requiring skilled database administrators. Comparison and choosing the right DBMS. MySQL is a great choice for beginners, web applications, and developers looking for a simple yet powerful relational database. It's also ideal for small to large-scale web-based applications. PostgreSQL is suited for complex applications that require advanced features, data integrity, and extensibility. It's preferred by developers working with complex data types or large data sets. SQLite is perfect for small-scale applications, mobile development, and situations where simplicity, portability, and lightweight are the primary requirements. Oracle is designed for large enterprises that need a highly secure, scalable, and robust system for handling mission-critical applications and massive data sets. Each DBMS has its strengths and is suited for different types of projects, so the selection depends on your specific needs in terms of scale, complexity, and budget. Thank you for watching this video.